All right, this is two skis walk into an... Sorry, it's two skis walk into a R. I'm Ray.
I'm Brian.
It's so confusing and hard not to say an R, but it's a R. So we're going to talk about objects and different kinds of objects in R. And the first hard to define thing is, what is an object? And I think you and I, before we started recording this, came to the conclusion that it is really any stored and named piece of information in R that you can then do something with.
In R, you're going to be using objects a lot. So really, when we're thinking about naming these objects and storing information within them, we want to have a good, consistent protocol of how we actually accomplish that task.
Right, and naming them is up to you, and you can really name an object anything you want. You could name something, you could give it a stupid name, like just type all over the keyboard like that, although that wouldn't work. That's a bad idea. Probably a better name would be something like plant C, maybe for plant carbon. I don't know. Mm-hmm. And maybe I have a value for that. The assign operator is what we use to assign information to an object, and it's a little, I guess, less than sign and a little minus sign. So plant C, maybe I'm going to say is 44.
Mm-hmm. And you'll notice that less than sign and the minus sign actually forms a little arrow.
Yeah.
So you're pointing to where you want your information to be stored within your object. So 44 would be stored inside of the text called plant C.
Right. So now if I run this line of code, you'll watch over here, we're going to populate. All of a sudden, we now have this object called plant C. Mm-hmm. That's kind of cool. I could also make an object called plant N, and maybe that is equal to 3, and now I could run that. Mm-hmm. And now check this out. I could divide both of those. So I could have my C to N ratio. So I could do plant C divided by plant N. And if I run that, I get the value of those two things divided. If I made a mistake or I want to change this to, say, 41, then I could rerun that. And then I could go back here, and it's going to change that answer because I now have a new value for plant C. So maybe I got ahead of myself there, Brian. These are objects, and what are the naming conventions for these?
So when we're thinking about naming an object, you want to make sure, first of all, that it makes sense for the data that you're going to be storing inside of that information.
Yep.
So you wouldn't want to call this animal C when you have plant C is with the thing that you measured. Another way that we are going to be approaching the naming of objects is you're going to be probably typing this information over and over and over. So you want it to be something simple enough where you have a complete understanding of what information is in that object, but also you don't want it to be too strung out, if you will, because you don't want to have to type plant carbon over and over again.
Right.
You would want to type in plant C. It makes it a little bit more efficient.
So P is probably too short, and in some circumstances it might be okay, but that doesn't give you much information. But you also don't want to do like, this is the plant C that I measured at the beach. Although I think it would accept this.
It would accept that.
It would accept that, but that's a terrible, oh my gosh.
But who wants to type that again?
That's ridiculous.
And also remember that when you're naming an object, that R is case sensitive and also space sensitive.
Right. So if I type plant C without, it's actually trying to help me out here by telling me what the right answer is. But if I do that divided by plant N, it's going to give me a problem. Yep, look, because it doesn't know what that object is. It really cares about capitalization.
So there's a couple of tricky letters, as you can imagine. So if you have a capital X and a lowercase x, when you have been staring at your R code for a few hours and you're lacking coffee, the capital X starts to look a lot like that lowercase x. So if you get those two capitalizations, either uppercase or lowercase, wrong, R will give you an error. Sometimes students don't ask for help right away. So they may spend a half hour on a simple calculation or capitalization error.
Yeah, I should point out my rule generally is if you're having trouble, like throw yourself up against it for a half an hour.
That's my rule as well.
And after that, just ask somebody because there's really diminishing returns on your likelihood of fixing that. And
it doesn't even have to be Ray or myself.
Yeah.
Often having a second set of eyes of a fellow classmate will actually help you out a lot because they haven't been staring at your code for the last half hour, and they can actually pick up that capital X versus that small
They can.
x.
We digress a little bit. You can also include periods within them, so it could be like plant.c. A lot of R coders like to use periods for reasons I don't understand. I don't know how you feel about periods.
I used to use periods, but I don't use them as much anymore.
Okay.
I did find some value in them when I was working with way more complex data sets. So sometimes I'd be moving from, which we're going to learn here in a little bit, about a data frame versus a matrix. If it was a data frame, I would use a .df. If it was a matrix, I would use .mx. Beyond what we need to do here, but it's just a way that R will recognize that if you have a period in there, you can still name that object.
It's just like any other character. So use it if you want, don't use it if you don't want. Fine. Cool. So we talked about naming objects. There's different kinds of objects. You've already seen numbers. So plant C and plant N are numbers. Another useful one would be a string. So I could say my plot title, maybe that's an object I want to make, so I can put this plot title on many plots, would be plant C to N values. So this is a string. I put it inside quotes. And now if I hit run, it's going to be stored there. And so I could use that subsequently. Anything else to say about strings for the moment?
So just to make sure that when you're putting any information into a string, we need to use the double quotes. The quotes are extremely important because if we remove the quotes and try to run that and to create an object, R will become confused because it doesn't know what the plant C to N values actually means. It's meaningless to the program.
Yep.
So we must actually explicitly put the information that we want as text in quotations.
Oh, I thought of one thing. So sometimes RStudio tries to be helpful by throwing in extra quotes, and sometimes it'll mess you up. I can't think of exactly how that would happen in a situation like this. But just be aware. Sometimes it's trying to throw in double quotes, and it'll mess you up. So it falls all over itself to be helpful. So we got strings. We also have logical. So I can name an object is higher, and let's make that true. So that object will store the value true. And if I do something down the road that involves evaluating logical true-false stuff, I can put that object in there.
And so R will recognize two different types of information for true. You can actually also use just capital T.
Oh.
So capital T or spelling out the word true will both give you the same stored condition.
Look at that. I just learned something. Thanks, Brian.
You're welcome, Ray.
Cool. All right, so that's logical. We also have vectors, which now it's getting crazy. A vector is a series of numbers or a series of objects.
Series of characters.
A series of characters could be a vector. So I'm going to do mult plant C, and the way you make a vector is with C parentheses.
So C actually stands for the word combine.
Oh my God, I learned something else.
I'm here to teach everybody, right? So C actually means combine. So when you are going to be putting information into a vector, you are going to be combining these all into one single object in this particular case.
Right, so I combine 3, 6, 7, 8. And so if I hit run, now I saved multiple plant C, and it's got those 4 values.
And so let's show the results of what's in that object.
Okay, so if I just go down here and type mult plant C and hit return, it spits out what that object is.
So you'll now see that there's stored information in mult plant C.
Right.
And to make our vector, it's very important that we get the syntax correct. So we have to have C in parentheses, and then we also then have to separate each of our values by a comma.
Yep. And now it's cool. You could do math with a vector. I'll just show them real quick. So we'll just do like, let's do mult plant C times 2. What's gonna happen?
It
works.
works.
Look at that. It multiplied each of the values by 2. That's pretty cool.
So it's iterative.
Yep. And you could multiply 2 vectors. So I could multiply this by C1, 1, 10, 100. I hope this works. It did. Look at that. 3, 6, 70, 800.
But Ray, what if I wanted to multiply it by our original plant C value? Can we do that?
What are you talking about? Like,
so if we take that value of 41 that's stored in plant C,
you're right.
Can we actually multiply that together?
I bet we can. Let's do that. Look at that.
Because it's all about stored information.
Yep.
So we stored our value of a single value of 41 in plant C, and we also have this vector with our series of numeric values. We multiply those two together, and it iterates through each of those numbers within that vector.
Excellent. Cool. We also have, data frames. Okay. So without going into it, I'm going to do something called, I'm going to call an object ray CO2, and via total magic, I'm going to import a data set. Right? This is going to work, Brian, isn't it?
I have faith that it's going to work.
It did. Okay, cool. So a data frame is very special, and you'll use many, many times because it's very much like a spreadsheet. In fact, you should just think of it as a spreadsheet. It can combine different types of data. So we've got strings, numbers, and numbers. And each entry is just like on a data sheet assigned to an individual data observation. So this would be the first observation, concentration 95, uptake 16, and so on. So you can do and will do all kinds of things with data frames.
So the thing that separates the data frame from the vector is that a data frame must have not only columns, but it must have row. So it's going to be a data frame which is going to require at least one row and one column in order to put that information into what we have, a specification called a data frame for that object. And
I can pick off columns of that data frame by typing its name, so ray CO2, and then I do a $, and then I can select any of those columns. So if I do treatment and then we hit run, it should spit out all of those values that we saw previously when we looked at treatment, non-chilled, chilled, and so forth. So you can pick off columns, and we'll do all kinds of useful things with that.
So Ray, can we do math with the columns that we choose?
I think we can. So we could do ray CO2, $, let's do concentration divided by uptake. I don't know if that makes any biological sense, but we can do it. R will do it. Right? Let's do that. And we could store, no, let's not store that as an object. Let's just spit that out. Yep, it spat out all that math. Cool. If I did want to save it as an object, I could save it as ray crazy division. And then we would save all of those things as an object, right? So now we've got all that stuff. If I wanted to save that in the data frame itself, I could do that too, couldn't I?
We also can.
Oh my gosh, ray CO2. I'm going to make up, so $, and then I'm going to make up a new column name. So crazy div. And then I'm going to just copy this thing right here, paste that thing right there, and run it. And if you watch, right now we have 84 observations. That's rows of 5 variables. When I hit run, it ought to jump to 6 variables. It did.
It does.
So now we go check it out. And look, crazy division is now one of the columns.
So this is a really important point, which students often forget. So if you want to make a new column in your existing data frame, just going back to reiterate, we have ray CO2, which is the original object that we have that is designated as a data frame. and then we do the $sign, and then we give it a brand new name. So we're going to then put the information with the assign function with our mathematical formula, and it will make a brand new column in your data frame. And we can use that later on down the line.
Great.
So it's just a good reiteration there.
Right. And then the last one that we should mention, anything more to say about data frames at this point, Brian?
At this point, I think I'm feeling that we covered it.
Okay, cool. So I'm going to, this is a lousy name, but my list, because I don't know what this even is. You can make lists of things, and lists of things can be like a whole, like they can be different kinds of objects. It's just a collection of different objects. And I just want to make you aware because sometimes down the road you'll need a list and a vector won't do. So I can make a list of a character followed by a number followed by my, could I even throw my data frame in there?
I think you could.
Oh, let's go crazy. So let's put my data frame in my list and oh my gosh, I think it worked. Okay, cool. So if I click on this thing, I see, oh yeah, hello, number, and then it's got like all this gobbledygosh that goes along with the data frame that I slapped into that list. Cool. Anything else?
I think that covers it for exploring our data frames and naming our objects.
Yes, objects, objects, objects.